Okay, let us now solve problems involving uniform circular motion. Here's for our example. Problem. What is the centripetal acceleration of the Earth as it moves in its orbit around the Sun? Pag-aralan nga natin ano ba yung alam natin dyan sa pag, pag-move ng Earth around the Sun. Okay, kuha tayo ng mga pictures. Okay. So maybe in Google we have some pictures. Okay, here. Meron ako nakuhang picture sa Google, and if you try to notice, this is the sun. The sun is the center of the solar system, and moving around it are the planets with their respective orbit. Itong mga maliliit na lines na to, yan daw yung orbit niya, no? So it seems like it is moving in a circular direction, and the distance from the Earth to the Sun is somewhat the radius, okay, of this circle. Ngayon, yung Earth daw yan, kung halimbawa dito nagsimula, yung Earth daw ay nakaka-complete ng isang buong revolution within 365 and 1/4 days. So, anong alam natin? Ang alam natin yung time to be T is equal to 365.25 days. Ngayon, gaano raw kalayo naman ngayon yung Sun sa Earth? So, ang layo daw ng Earth or nitong orbit na to doon sa Sun is approximately, sulat natin ha, 1.4. So that will be the radius is equal to 1.496 times 10 to the 11 power. Okay, raised to 11 power. Wala pa lang 11 power to, so gawa na natin ng paraan. We will just have to raise this to 11 power. Okay, so yan daw po yung ating mga given. So kung meron tayong Earth, pangatlo pala yung Earth, ano? Mercury, Venus, Earth, Mars, Jupiter. These are called the inner planets, and these are the outer planets. Okay. Now, so yung Earth, kung ito yung starting point niya, it will make one complete revolution in 365.25 days. At yung R niya is 1.496 times 10 to the positive 11. So, ganyan yung simula ng ating magiging solution. Let us erase this now. And we are now going to solve this problem. Yung centripetal acceleration is equal to V squared all over R. Ngayon, yung V natin, yung V is equal to the displacement over the time. Ano naman itong displacement na to? Itong displacement na to, that will be the one complete revolution. So, yung one complete revolution, just like the circumference of the circle, that will be 2 pi r, or divided by t, or the time. So we're going to substitute this one here. The centripetal acceleration, that is the unknown, is equal to b squared, which is 2 pi r divided by t, and then we have to square that because that is b squared. We square that, and that is divided by r. So we have to square each term. So we have 4 pi squared, and then r squared over t squared all over r. Okay. So we are now going to cancel this r with 1 r there. We are left with this equation that is 4 pi squared. And then what is the r? 1.496. 1.496 times 10 to the positive 11. And then divide that by t squared. So what is this t squared? Remember, this is in days. So let us solve. T will be equal to 305, okay, 0.25 by 24 hour a day. So 24 hours per day. And we are going to cancel it out. After which, we are going to multiply that again by 60 minutes per hour. So we multiplied by 60, and we are now in minutes. Okay, minutes per hour will now be cancelled out. Okay, that will be cancelled out. Finally, we're going to multiply that again by 60. That will be seconds divided by 60 seconds per. So we have 365.20 multiplied by 24 hours. So multiply that by 60, then multiply that by another 60 seconds. So that is 31,557,000, and then we are having 600 seconds. One is in squared. Okay, that will be second squared. So we have to square that one. Still have to square that one because this is t squared. No? So we have here 4 times pi squared. And then times the quantity 1.496 exponent positive 11 also equals tayo, no? Divide that by the quantity 31,500,600, and then we are going to square that, and the answer is okay 0.00593 530. Okay, that will be our answer. 593039. Okay. Meter per squared. That will be squared. So 1, 2, 3, 5.93 times 10. So that is equivalent to 5.93 times 10 to the negative 3. Okay, so that will be it. This is our answer to this question. Okay, we have another problem here. A 900 kilogram car moving at 10 meter per second takes a turn around a circle with a radius of 25 meters. Determine the acceleration and the net force acting upon the car. So we have listed down the given here. We have a given of 900 kilogram which is the mass of the car, and we are given a velocity of 10 meter per second and the radius of the circle, which is 25 meters. We are asked to determine the acceleration. When we say acceleration, this is a centripetal acceleration and the net force, so acting upon the car. So we try to illustrate the problem here. There is this circle. The radius is equal to 25. So this blue one is equal to 25. And there is this car which is having a velocity of how much? 10 meter per 10 meter per second. Okay, that's the velocity. Now, tandaan natin ang hinihingi sa atin yung net force. Okay. Yung net force na to, wala tayong ibang given. So there is no mu that is given. There is no mu. Therefore, we are going to neglect friction. Ano? Neglect friction. Okay. Otherwise, kung may binigay na mu, what will happen is we get the F net. Okay. The F net of that one. But in this case, we do not have mu. We are going to neglect the friction. So the only force that is acting on this one, the net force that is acting on this one is F sub C, which is the centripetal force. So yan yung ating isosolve, ano? Wherein F sub C is equal to the mass multiplied by the acceleration. Sabi nga natin, kung centripetal force to, centripetal acceleration din dapat to. Okay. So this is the working equation that we are looking. But before we can solve for this one, we need to solve for acceleration. The centripetal acceleration is given by the equation b squared over r. So ano yung b squared? Ano yung b natin? B natin is 10 meter per seconds and then quantity squared. What is r? R is 25 meters. 25 meters. Okay, this one, this is meter squared per second squared. One of the meter will cancel out. Therefore, the value of this one will be in meter per second squared. So that will be meter per second. Once we get the value of this one, we can get F sub C, which is F sub C is equal to, what is the mass? The mass is 900 kilogram, and that will be multiplied by whatever is this one. Okay, that will be in meter per seconds. Therefore, ang ating magiging unit will be kilogram meter per, this one is kilogram meter per second squared. Ating magiging unit is in Newton. That will be kilogram meter per second squared. So let us grab a calculator. So we grab a calculator and let us see, that will be 10. And then we square that and then divide that by 25. So that will be 4. So this one will be 4 meter per second squared. So meron tayong 4 dito and i-multiply lang natin sa 900. That will be 3,600 newtons. Okay, that's how easy it is kapag walang masyadong ibang forces kapag yung Fnet natin is equal to the centripetal force. But there are times na ikino-consider natin yung friction, then simple lang din naman yon. We just have to sum up forces and apply Newton's second law is equal to summation of forces is equal to F net. Okay, so that F net is equal to and then we equate that zero. This is a Newton's second law of motion. If in case we are going to consider the friction, but in this case there is no mu that is given, so we have to neglect that, and we arrive at this answer. So there you have it, your answer for problem number 2. Okay, we have another problem here. A 95 kilogram halfback makes a turn on the football field. The halfback sweeps out a path that is a portion of a circle with a radius of 12 meters. The halfback makes a quarter of a turn around the circle in 2.1 seconds. Determine the speed, acceleration, and the net force acting upon the halfback. Now, I highlighted this 95 kilogram halfback here uh, to show what is the definition. I put here the same highlighted. So, yung halfback pala, offensive player sa American football, ano? So, in short, yung halfback is a football player. Okay? So, ganun na lang natin tinanong. A football player makes a turn. And we are given the mass of that football player, which is 95 kilogram. And we are given the radius of which he turns on a circle. And the distance that he traveled is one-fourth of that 12 meter radius circle. Okay. Now, we are required to find the velocity, okay, and then the acceleration, and also the net force that is acting on the halfback. Okay, so we we will solve first for the velocity. Let us make it blue. So we solve for the velocity. Okay, we have the solution. Velocity is equal to the distance or the displacement over time. Okay, but what is the displacement of this halfback of this football player? That is actually quarter of a circle. The distance that is traveled by the halfback or the football player is one-fourth of the circumference of the circle. So that is actually 2 pi r, which is the circumference of the circle, divided by 4. Or we can just multiply that by 0.25 because that is one-fourth. Okay, 2 pi r divided by times 0.25. Divide that by the time. So what's the time? That is 2.1 seconds. Okay. So this one is in meter. So we are having an answer that is equal, that is having a unit of meter per seconds. Okay. Now, upon knowing the velocity, we can compute for the acceleration. So the acceleration, and that is a centripetal acceleration, of course. That is actually b squared b squared over r. Okay. So whatever is the value of this b squared here, that will be going here, and that will be divided by r. What is r? R is 12 meters. 12 meters. So this one will have a unit of meters squared per second squared, and that is divided by another meter. 1 meter will cancel out, therefore we will be having meter per second squared. Okay, that's the value of our A. And then we have the F net. The problem doesn't state any influence of friction, so the F net will just be equal to the centripetal force. We neglect the friction, that will be equal to the mass multiplied by the centripetal acceleration. Okay, whatever is the value of this one will go here. Therefore, we have here the mass, which is 95 kilograms. Okay, we have here 95 kilograms, and that will be multiplied by the value of this one is in meter per second squared. So we will be arriving at an answer with a unit of newtons. Okay, that will be in newtons. So let us grab a calculator. So we grab a calculator and reset it. That is 2, and then pi times 2. 2 pi r is 12 times 12 times 0.25. Divide that by 2.1. And we have 8.97 meters per second. 8.97 8.9759. Okay, 759 meter per second. And then if we have here uh, 8.9759, so let us write here 8.9759. Okay, and then we're going to square that divided by 12 meters. So let's grab that calculator. We have 8.9759 squared, and then we divide that by 12. We have 6.7138. 6 point, that's 7138. 7138. And we substitute this value 6.7138 into in here. So let us substitute 6.7138 here, and we have to multiply that by 95. 637.8203. 637.8203 in 4 decimal places. That will be Newton. That is our answer. Okay, I have shown you how to solve simple problems in uniform circular motion. We have another types of problem here, but I prepare to cut this video for ease of uploading. I will be coming up with part of this video tackling some complex problems involving circular motion. Not only uniform circular motion, but also non-uniform circular motion and pendulum problems. So, with this, before I leave you, I will be giving some more problems. I'm leaving you with some problems to solve involving uniform circular motion. Here are your practice problems.